Hey guys, it's STEM with Sid, and today I'll be going over Extrema on an interval. Now, I'll be briefly going over the theorem for it, but pretty much the Extrema value theorem is if f is continuous, write this cleanly, if f is continuous on a closed interval, a to b, then f has both a minimum, and a maximum. That's it. And basically the minimum would be the value, let's say a function f of x, and that value is c. That would have to be less than all the other fx, less than or equal to all the other values in that range. And if it's a maximum, for maximum, it has to be greater than or equal to the value has to be greater than or equal to any value in that range. And to find relative extrema or critical numbers, you just have to find when f prime equals 0. Because what is when f prime is 0? That's the tangent line, or the tangent line or the slope. If the slope is 0, your tangent line is relative min max. Yeah. If the tangent line is a horizontal line, then when is that possible? That's only possible at a max or min. Because let's say this is your total graph, where this is your min and this is your max, right? Min, max. Now look at these look at these relative min and max. They have horizontal slopes. The slope is 0. Basically, it's changing from increasing to decreasing, or decreasing to increasing. So yeah, you just you find the derivative, set the derivative equal to 0, and whatever x value you get, that will give you the value in which the x value in which it is a relative min or max. And how do you know which one? Plug in a value for the derivative that's less than that x value. Like let's say you get x equals 3 for it to equal 0. Plug in 1 and plug in 5 or something like that. If 1 gets positive and 5 gets negative, that means the function was increasing because positive slope. Then it was decreasing, and you know that it's a relative max. If you have where it's negative slope and then positive, it was decreasing and then it was positive. So it's a relative min. And that's basically what's a critical number, basically. It's defined as the derivative equaling to 0, or f is not derivable. So let f be defined at c. If f prime of c equals 0, or f is not differentiable by c, so if f prime of c does not exist, then c is a critical number. Then c is I'll put cn, but critical number of f. And relative extrema only occur at these critical numbers. So you're only going to get a relative min or max at the critical numbers. And basically that's pretty much it. So for finding extrema, your largest value is the max, your lowest value is the min. You take the derivative of it, and if it equals 0, it's a critical number, or if it does not exist. And you check before and after to check if it's a min or max. You can do this with really any function. You just take the derivatives, plug in your values, and check how it's changing. The slope could be increasing, then decreasing, or decreasing and then increasing. And then you can figure out the extrema. Thank you for watching. I'll see you next time.